Hello students, and welcome to this calculus video. In this lesson, we're going to start talking about average value of a function. So I really want you to think about, okay, how were we finding average before? Not just in position, not just in velocity and acceleration, but like think back to before. You would normally like add things up and then divide by the amount of results that you had. So that's going to be very similar to how we're going to do it moving forward, just using some calculus. So grab your calculators because you're going to need it in both of the videos in this lesson, and let's get started. You might recall, okay, average velocity. You know, if we're going from on an interval from A to B, you're just going to go y2 minus y1 over x2 minus x1. Same thing with average acceleration, except this time you'd be using the velocity. So we've kind of been doing that before. And like I said, we're basically just pulling that information from algebra 1, finding slope. So now what we're going to do is I want you to think about, okay, how would we do this when we're actually writing this out using equivalent forms with integration. So over there on the left are your integration forms. You have 1 over b minus a. So if we're going from a to b, from 1 to 4, you just go 1/3. And so that's how you take that average, and then you just take your integral from there. So as I'm writing this out, think about this. Okay, what's the integral from a to b of a of t dt? Well, since we're taking a step up in PVA, so here's a, we're going up to v, well, we're ending up with 1 over b minus a times b of b minus v of a over 1. So you might look at this, all right, this is essentially what we have above. This is average acceleration. And the same thing if we're doing this with velocity, we again have 1 over b minus a, and we're just multiplying this by p of b minus p of a over 1. And I'm putting in over the 1 because that's essentially what it would be for that integral. It'll be over 1. And so what is this equivalent to? Well, this is average velocity. So what's important to remember here? Well, as I'm looking at these, what's important to recall is going to be, all right, if I'm asking you to find the average acceleration and we're given something, some sort of integral or some sort of function, then you're going to be using the integral now. And remember, integration is adding up those things and dividing by the number of results. That's the exact same thing that you're doing here, just using integrals. So don't forget that, like, integration just means you're adding things up. So it's really going back to what you were doing in middle school when you learned averages in the first place. So if we're ever saying, all right, what is the average value of a function on an interval? Well, we know that that's going to just be 1 over b minus a times the integral from a to b of f of x dx. So now let's look how this works out with a couple of examples. This first one we're going to do on our calculator, but I do want us to show our work. We're going from 1 to 3 and our function's given to us. So I'm going to go 1 over 3 minus 1, so that's going to be 1/2. And we're going to do this from 1 to 3. And I'm going to write my function in here, x cubed times the square root of sine squared x dx. And that's something that I can just type into my calculator. So let's go ahead and do that.
There's a party downtown, someone said that you're coming by. I know that summer was a big mistake. I just hope that we're still okay.
All right, and again, rounding to 4 decimal places, I'm going to get my results here, and we see it 5.8482. So this is approximately 5.8482. So now let's go ahead and do one that is not going to utilize the calculator. We want to find this average value of f of x 2 minus 4x from 2 to 6. So what is my average going to be? Well, 2 to 6, that's going to be 1/4. And we're going here from 2 to 6 of my function, 2 minus 4x dx. And let's see what this is going to be equal to. Obviously, we're going to have 1/4. And then I have the upper bound. First, I need to find the antiderivative. So that's going to be 2x minus 2x squared. And we're evaluating this from 2 to 6, just like what we've done before. So I'm gonna still have 1/4, and then I'm gonna substitute 6 in my upper bound. So that's gonna be 2 times 6 minus 2 times 6 squared minus my lower bound, which is going to be 2 times 2, minus 2 times 2 squared. Okay, let's evaluate all of that. Again, no calculator. So it's going to be 1/4. I've got 12 minus 36 times 2, so 12 minus 72. And then this is going to be minus 4. And then 2 squared times 2, but this is all going to be addition. So 2 squared is 4 times 2 is 8, so plus 8. Okay, so let's do everything inside of that bracket real quick. 12 minus 72, that's going to be negative 60. So negative 64, or actually negative 60 plus 8, that's going to be negative 52. And then minus 4, negative 52 minus 4 is going to be negative 56. All right, so doing that negative 56 divided by 4, this all comes out to be negative 14. So over some sort of time, we're going to be looking at applying this in our next video, where we're actually applying, okay, what does an average mean in a situation? So hopefully you remember your antiderivatives, and you're going to see how we can actually start to begin to apply definite integrals as we continue to study calculus. Of course, if you do need any help in this video, reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.